We're live. What's going on, guys? What's going on? Did we have a good weekend? That's how I had to wake up. A little tired. Don't know why. Maybe it's because it's cloudy outside. It's gloomy. You know? When it's cloudy and you just don't know what to do. But this is section 11. We are in a new chapter. Yay. Awesome. It's going to be great. Hopefully there's no lag. I don't know why it's saying that there's like some lag. Let me see if there's anything else down. No, there's nothing else. I don't know. But yeah, how we doing? We doing well? We chilling? Are we chilling? Wow, we're quiet today. Is my mic muted? Oh, fine. There it is. Finally, we got someone to reply. Yay. Well, I'm glad that you're doing fine, Bob. I'm glad that you're doing fine. Chilling. We're all chilling just a little bit. But yeah, like I said, we're in a new chapter. This first part of this chapter, we go over rational expressions and how to add them together, how to divide them, how to simplify them. Dude, am I lagging? Do you guys know if I'm lagging or is everything okay? I need some feedback here. Because it's like, this thing is like spiking. This little meter. There's lag. Why is there lag? Everything looks healthy. It just showed like this big spike. Yeah, it's weird. I don't know what to do. It's been lagging all day. I don't know why it's been lagging all day. But for some weird reason it has. I don't know. But the main piece that I wanted you guys to get from this section is the only thing that reduce are factors. Like factors reduce. Factors is multiplication. If you see things that are being added and subtracted, they do not reduce. Only multiplication reduces. Let me give you an example. If I had x plus 2 over x minus 1, these x's do not reduce. Okay? You cannot do that. What I just did here, that is a big, fat no-no. You cannot do that. They do not reduce. And the reason why they do not reduce is because they are not factors. Factors means multiplication. This says x plus 2. That's not a factor. This is x minus 1. That's not a factor. They have to be factors for things to reduce. So when we look at number 1, when it says x times x times x over x times y, these are all factors because this is multiplication, which means if you have the same factor in the numerator and the denominator, they are going to reduce. So those reduce. And so my answer would then be x squared over y. So we really, really, really have to remember that. We really have to understand that factors reduce. Let's look at number 2. So if I have 4 times x minus 3 cubed over 8 times x minus 2 squared. So this 8 is the same as 4 times 2. Well, the factor of 4, those will reduce. Now, this x minus 2, that's a factor. There are 2 of those in the bottom, and there are 3 of them in the numerator. So, if I want to visualize this, if I said I had x minus 3, x minus 3, x minus 3, and on the bottom I have x minus 2 and x minus 2. Do this x minus 2 and the x minus 3? Are they the same? Can I do that? I know there's a pause. But the answer is no. You cannot do that. That is a big, fat no. Thank you, Bob. I appreciate your participation. You cannot reduce those. And the reason is they are not the same. So the only thing that reduces is the 4 and the 8. So my final answer is going to be x minus 3 cubed over 2 times x minus 2 squared. Comments or questions on that? Okay, so moving on. Number 3. X squared plus 8x over 4x plus 32. Now the question is, do something reduce? We don't know. Something could reduce. Right now, as it stands, when we just look at it how it is, nothing reduces. And the reason is, there are no factors that are the same top and bottom. That is the reason why it does say state the restrictions. I will get back to those. Thank you, Janal. My microphone is literally sitting like right in the middle of that part of the worksheet. So I had to like move out of the way to take a look. So I'll go back to that. But so right now it's not factored. There are not factors. And so that's why the word factoring becomes important, is because factoring literally means to express as multiplication. So if I had 8 and I asked you to factor 8 and you said 2 times 4, I'm taking 8 and I'm expressing it as multiplication. So we have to factor this. We have to express it as multiplication to see, are there similar things in the numerator and the denominator that are going to reduce? So in this instance, on the top here, there is an x that I can factor out. So I get x plus 8. And on the bottom, between 4x and 32, there is a 4 in common. And so we have x plus 8. And so we have an x plus 8 that's the same factor on both the numerator and the denominator. And so those are going to reduce. And so I'm going to be left with x over 4. So now let's talk about those restrictions. The restrictions are basically x cannot equal whatever's in the denominator. That's going to make it 0. So if we look at this original piece here, if I have this 4 times x plus 8, what happens if hypothetically x is going to be negative 8? Well, if I plug in negative 8 plus 8 is 0. 0 times 4 is 0. Well, I can't divide by 0. So in this instance, my restriction is x cannot equal negative 8. So it's basically you set the denominator equal to 0 and you solve, and x cannot be those values. So going back to number 2, x cannot be positive 2. Because if I have 8 times x minus 2 squared, well, x can't be positive 2. Because if I plug in 2, 2 minus 2 is 0, 0 squared is 0, 0 times 8 is 0. Well, I'm dividing by 0. That's undefined. On number 1, I have both an x and a y in the denominator. So x can't equal 0 and y cannot equal 0. So I actually have two restrictions because I have two variables. Comments or questions on that? All right, number 4. So we have x squared plus x minus 12 over x squared minus 16. So to see if it simplifies, I have to factor this. So if I factor this, I'm going to get the top factors into x plus 4 and x minus 3. The bottom factors into x plus 4 and x minus 4. So I have to look, what are the same factors in both the numerator and the denominator? That's x plus 4. So those will reduce. And so I'm going to get x minus 3 over x minus 4. So that is the reduced value. Now my restrictions. I have to look at what was it before I reduced. So these are the values. Well, x can't be what makes me have a 0 in the denominator. So for this first factor, x cannot equal negative 4. And for this next one, x cannot be positive 4. And so those are my restrictions. Comments or questions on that? Okay, so let's look at number 6. So we have to remember our tangent parent function. Looks something like that. Dot, asymptote, dot. There is a reflection. There's a negative in front, so that's going to cause it to be the red. It's going to flip over the x-axis, so just remember that. We have to take whatever's on the inside here and put that between 0 and pi. So we're going to add pi to everything. And then multiply by 2. Now you're thinking, wait, isn't it between 0 and 2 pi? It is 0 and 2 pi for sine and cosine. It is 0 and pi for tangent. And so here's our box, dot, asymptote, dot. And so add them together, you get 6. Divide by 2, you get 3. And so that's going to be the middle value there. So now, drawing the sketch, we'll say every single tick mark is going to be pi. And so we know that this is dot, asymptote, dot. So 2 pi and 4 pi. I'll make the red my asymptote. And then the green. There we go. Any questions on that? Uh-oh. Number 10 has a typo. That's supposed to say 0. All right. Or sorry, number 11. Finding the inverse. Let's look at number 9. So the first thing we need to do is we got to switch the x and y. That is the definition of an inverse, is the domain and range are going to switch. Now I just need to get y by itself, so I'm going to add 3. Now y is in the denominator, so I want to get it out of the denominator. So those are going to cancel out. And then now I get y plus 7 times x plus 3. That's going to equal 1. So now to get y by itself, I need to divide by the x plus 3. So I get y plus 7 equals 1 over x plus 3. Subtract 7 on both sides. And so you get y equals 1 over x plus 3 minus 7. Now to verify that, we just have to take it. We have to take this value and we have to plug it in to our original. So y equals 1, sorry. That's not how we want to write it. We just want to say 1 over, and then instead of saying x, it's now going to be 1 over x plus 3 minus 7, and then now I have the plus 7 and then the minus 3. So this right here was the x, because it's 1 over x plus 7 minus 3. The 1 over x plus 3 minus 7 is my x. So this is the x value. So then the negative 7 and the positive 7 are going to cancel out. When you have 1 over something, that means you flip it. So 1 over that means I need to flip the 1 over x plus 3. So I get x plus 3. And then those cancel out. And so I'm left with x. And that's how we can verify that it's an inverse. And my screen blocked it. There you go. Sorry about that. But all you have to do is just take this and you plug it back in for x. I know I had already switched x and y here. That's why it doesn't show x. All right, on number 11, or any questions on like number 11 or what the heck, why did that cut off? Number 10 or 11, remember you just solve, you put the values on a number line, you test true or false. We've done that so many times in this class that we should be experts. Any questions on 12 or 13? All right. So, just to kind of give you guys an update, this is the last section that's actually in the CPM. There are a couple of outside things that I will be covering afterwards that we're going to be going over to make the transition to pre-calculus pretty easy. This is not an overwhelmingly large section, so just know that. Summer school, yes. Are you taking a pre-calc over the summer, Bob? Is it too late to sign up? No, it is not too late to sign up. Just email Mrs. Brownlee. I put her email address out there in the general chat, so you just need to email her. Cool. Well, I think that's it. Yeah, no problem. Like I said, this is actually not a very overwhelmingly long section. There's like one dense topic that we're going to approach, but other than that, this section is pretty flat in my opinion. Do you know if summer school is going to be online? It is 100% online. I am currently developing the learning management systems as we speak, and there will be some required online participation, things like that. So, yeah, I mean it's still within the boundaries of a flipped classroom model. You'll be doing majority of what you're doing at home. You'll be taking tests and stuff like that online. Um, it's not going to be bad, but whatever my where these are like, what we're doing right now is online. It's kind of like it's not mandatory. It's voluntary. For the summer school class, the I will be doing some online sessions, and during those online sessions, you will be required to participate. It's like your attendance. You have to sign in for it, and if you don't sign in for it, then you get marked absent, basically. So you don't have to say anything. You just have to be there. But I think that's it. Cool, guys. I really appreciate you. I really appreciate for you guys showing up. Work hard. Continue doing the best you can. I know with these weird circumstances, but I hope school and all that different stuff is going smoothly. So, yeah, no problem. All right. Signing off. You guys have a good one. And I will see you tomorrow.